Over my 3 trials, we can see that my heart rate significantly decreased over time. My resting heart rate was 101 beats per minute, and my last diving heart rate was 64 beats per minute. This is due to the mammalian dive response. This response occurs when your body is submerged in cold water and has no access to oxygen. The nervous system first recognizes the change in environment through trigeminal nerves on the face and through sensory neurons, sends a message to the interneurons in the brain, which tells the motor neurons in the respiratory system to go into apnea and stop breathing. The interneurons also send a message to the circulatory telling it to slow the heart rate and to constrict blood vessels to conserve oxygen. The brain also sends a message to the circulatory system telling it to redirect blood flow to the heart and the brain, and to stop giving blood to non-vital parts of the body so the brain has more oxygen. This is called a hypothermic coma. Although our experiment was not to this level, we still got results when the brain told us to stop breathing and our heart rate slowed.
Produce lactic acid as a waste product when you are metabolizing food. When the body is in the mammalian dive reflex, your metabolism shuts down, which prevents lactic acid from being produced. However, some parts of the body still produce it, and this can cause a buildup because the organs that get rid of lactic acid aren't being put to use. If someone is hypothermic and has a buildup of excess lactic acid and is warmed up too suddenly, the lactic acid can go into their bloodstream and acidify it, which can cause death. In order to prevent this, people who are hypothermic are warmed up again gradually so that lactic acid is not released at once.
After having gone into the mammalian dive reflex and having no heart rate for 50 minutes, Gore Otteson was resuscitated. During his time in the hospital, his brain was put into a hypothermic coma. This is when all the oxygen was being directed towards his brain, and this allowed it to recover from the lack of oxygen. When Gore was finally able to be warmed up, the medical professionals had to do it slowly to avoid releasing the buildup of lactic acid into his blood. After Gore's recovery, he was released from the hospital with no brain damage because of the human dive response.
When my head was submerged underwater, I thought of many similarities between the mammalian dive reflex experiment that we conducted and the mammalian dive reflex diagram that we were shown. First, just like the mammalian dive reflex, my respiratory system stopped functioning once I held my breath. It reminded me of when the little boy fell into the water and he wasn't able to breathe because there was no, his respiratory system stopped functioning because there was no O2 being able to go into his lungs, just water all around. When my face was submerged in the water, my sensory neurons and thermoreceptors began to alert my brain that there was a change in temperature. My head wanted to get out of the water, but I wanted to stay because I wanted to conduct the experiment. My peers told me that after 15 seconds, my heart rate began to lower drastically from my original heart rate. They got me thinking, is my heart going into bradycardia? Bradycardia is when the heart starts to be slower per minute, because to save energy, like limited energy and limited oxygen once under the water. So these were a couple of similarities that I found within the mammalian dive reflex experiment that we conducted and the mammalian dive reflex diagram that we were shown. Thank you.